Welcome students to your video on solving multi-step equations. What I would like you to do throughout this video is I would like you to copy the equation at the beginning of the slide. I would like you to pause your video, try to solve it on your own if you feel comfortable doing so, and then replay your video so you can see the solution. You may indeed be able to fast forward through some solutions for those of you who are able to do these without too much trouble. I do still expect to see notes come into class, especially the exceptions when you get to that section of the video. Let's get started. Okay, the ultimate goal when we're solving a multi-step equation is to isolate that variable on one side of the equal sign. And what we're doing is we are unwrapping. This is the terminology I used last year. We're unwrapping the variable. We're looking at what happened to that variable and we're going to undo it. Okay, unwrapping or undoing, which probably isn't a word, so it probably needs a hyphen in the middle there. So let's look at what happened to the number that we are dealing with here. So the number that we have is x. So that's the value that we're dealing with. First it was multiplied by 5, then 2 was added, and the result is 22. And what I want you to do is think about what are we undoing, what are we reversing, how do we go backwards from that? So the first way we go backwards is to do the opposite of adding 2, which is subtracting 2. Subtract 2 from 22 and we get, yes, that's right, we get 20. Very good. Then we're going to undo the times 5 by dividing by 5. We're going to divide by 5. So 20 divided by 5, what does that give me? Yes, that's right, I heard it. Someone said it, 4. So when we take that original equation, we can say, all right, 5 times 4 plus 2, is that 22? Yes, indeed it is. That's 20 plus 2. And yes, that's equal to 22. Let's fix the 0 there. Check. So our solution for that is x equals 4. Now this works great for doing mental math with our equations, but keep in mind your answers are not always going to come out to these nice happy whole numbers or integers like this one did. Let's jump in and start solving some equations in the traditional manner. Okay, kids, so we're unwrapping, undoing what happened to that variable. Most of the time, your first step is going to be to reverse addition or subtraction, and secondly, to reverse multiplication or division. We will look at exceptions to those rules in a few moments. Now again, if you are so inclined, please pause, copy your equations, pause your video, and then come back to view the solutions. Okay, for this one on the left, we have to reverse first either addition or subtraction, and we have subtraction. So we're going to reverse it, reverse the minus 17 by adding 17 to both sides of our equation. That's going to give me a 64 on the right, and negative 8z here on the left because the minus 17 plus 17 cancels out. Now we're reversing what now? That's right, we're reversing multiplication. Remember, if you see a coefficient, and that's the only thing you have left happening to that variable, you're always going to be dividing. Okay, excuse me, I'm sorry, I shouldn't say that. Sometimes you can multiply if there's a fraction coefficient, and we did see that in class. Alright, so we're going to divide here, and z comes out to be negative 8. You can check your solution by plugging it back into the original, see how it comes out. You should do that on your own. Let's move over to this other one. Again, we're reversing addition or subtraction. In this case, reversing a plus 12 with a minus 12. Cancels on the left, gives me a negative 17 on the right. Now I need to reverse the division that I see. Remember that now we have a fraction bar to show us division. What am I going to do to reverse division? I'm going to multiply. And I'm going to multiply by whatever we divided the variable by. So I'm multiplying by negative 2. That cancels there on the left and gives me 34 on the right. Again, check that solution if you would like to, and keep in mind that on a test or a quiz, you should always be checking your solutions. All right, continuing on. All right, exceptions to the rules. A couple of exceptions to the rules. I like to call this one the big fraction. Okay, so I want you to notice that you cannot start by getting rid of this minus 9 right here. You cannot, because that is not a minus 9. That's really a 9 over 4. So I can't say, okay, plus 9. No, I can't do that because of that fraction. I got to get rid of that fraction first. So we're going to do that, and we're going to do that by multiplying our entire equation by 4. So on the left-hand side, that's going to be 2y minus 9 all over 4 times 4. The 4's are going to cancel. Divide by 4 times 4 cancels. and then 11 times 4 on the right, giving me 44. So I now have 2y minus 9 equals 44. And from there, I can go ahead and finish solving the equation. So from here, it's just like the other two-step equations. Reverse my subtraction, add 9, 2y equals 53. I'm going to give myself more space. 2y is equal to 53. Divide each side by 2. Y is equal to 53 halves. You're going to leave it that way, and that's all right. Remember that not all answers are going to come out, not all solutions are going to come out to be integers. So it's okay to leave that. I don't want to see a decimal on that because remember when you're typing in your answers on an SOL, you have to type them as fractions as well. So to type that as a fraction, for example, I'd probably put, let's see, 53 over, where's my backslash? 2. So it would look like that, 53 over 2. All right, so we're ready. Let's look at another exception to the rules. Okay, great. On this one, we've got negative 18 equals negative 3 times the quantity x minus 11. Well, there's two different ways I can approach this. I can use division first, and start with division, or I can start with distributive property. It doesn't really matter to me what you do, so I'm going to show you both. Again, as we said, and I'll continue this throughout the video, if you want to pause it, try it, and then start your video again, that's fine with me. Alright, if we start with division, we can divide off that negative 3 there on the right-hand side by using a big fraction bar. And we can do that because this is negative 3 times a quantity in parentheses. And I am not changing that quantity in parentheses by dividing off that negative 3. And as you can see, that makes this a much faster equation to solve. Now I have 6 equals x minus 11. I can add 11 to each side, and I've got 17, and I'm done. So that's one way you can do a problem like this, and it really relies on the fact that that negative 18 is divisible by the negative 3. If it wasn't, you'd have to do it this other way using the distributive property. And in this case, there is another detail we're going to have to recognize and avoid mistaking. So it's going to start with distributing our negative 3. Now when you distribute a negative, I want you to notice that it's like multiplying a negative times a negative right there. So yes, we do have negative 3 times x is negative 3x. But the negative times the negative, or the minus times the, or the negative times the minus, turns out to be a plus 33. When you distribute a negative, that is a detail you have to watch out for. Continuing on, it's just like any other multi-step equation. Get rid of your addition by subtracting that 33 from both sides. That gives me negative 51 equals negative 3x. Well, now you've probably encountered another benefit of using this division method over here when it works out like it did with the 18 and the 3, because I don't know if you know your 17 times tables. I mean, I know I do, but I do this stuff for a living, so I know that 17. You might feel the need for a calculator in order to make sure you can find that. So that was another exception. I think we're going to look at one more exception to the rule, and then we'll look at what we're going to do in class after we have worked on solving some equations like this. Okay, 3/4 c minus 7/8 equals negative 1/2. I know, calm down. I know. Very few people like fractions. I get it. It's totally okay. This isn't going to be nearly as bad as you think, though. Let's go ahead and jump in, because I got a shortcut for this baby. If you want to do it on your own, do it on your own, and then start your video again so that you can see my special shortcut. Okay, I'm going to move it over a little so I have some more space. My shortcut is that I make the fractions go bye-bye. I don't like to deal with the fractions in an equation. Now, don't get me wrong. Fractions are so much better. Fractions are so much better than decimals. I don't like decimals. Okay, decimals, you have to do a lot of computation out. You have to worry a lot more about how accurate your times table use is in the middle of a problem, and I'm not always perfect with that kind of thing either. Fractions are just so much better because conceptually they're easier to use. There are tricks you can do that make things so much nicer. So let's go ahead, let's actually go ahead and use one of my tricks. Erase, 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 erase. Da, 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 da. I probably could have just deleted that, but I like erasing sometimes. It's fun. Okay, I'm going to use purple. You know how much I like purple at this point. You probably recognize that. We're going to multiply by the LCD. So what's the LCD of 4, 8, and 2? Now finding least common multiple or least common denominator is much easier if you use my little method. Look at your biggest number on the list. Did you find it? Yes, that's right, it's the 8. Look at your other two numbers. Does 4 go into 8? Yes, it does. Does 2 go into 8? Yes, it does. If you've answered yes to both questions, that biggest number is your least common denominator. And that's what you're going to multiply by. You're going to multiply this entire equation by 8. So that's 8 times 3/4 c minus 8 times 7/8 equals 8 times -1/2. Now, when you have a graphing calculator in class, it's going to be super, super duper easy to do this because you know you can put fractions in your calculator. And if you don't know that, I'm going to show you. But in this case, I want you to think conceptually. Okay, let's start from the right and move our way left. -1/2 times 8. We know it's negative because it's a negative times a positive. And the other thing I want you to remember is that half times 8 is the same thing as saying half of 8. I just blew your mind with that, didn't I? Half of 8. What is it? 4. So that's a -4 on that one. How about 7/8 of 8? Well, actually, this one's even easier because, look, our 8's cancel. So we have -7. And then over here, how about 3/4 of 8? What's 3/4 of 8? Well, ask yourself this. What's 1/4 of 8? 2. That's right. What's 3 of those? 3 2s? 6. 3/4 of 8 is 6. Wow, we just made that easy, didn't we? Finish it off by using your steps. Add your 7 to reverse the -7. Gives me a 3 there, gives me a 6c there. Divide by 6. Gives me a c equals 3/6, but I'm not going to write that. I'm going to simplify it. And I'm going to get 1/2. C equals 1/2. Now, it definitely occurs to me that I did not check the last couple. You can go back and do it yourself if you choose. And if you're taking a test or a quiz, of course I recommend that you always check your work. But that's not an essential thing in your notes because I'm telling you that's the right answer. If you prove that I made a mistake, so be it. But I'm pretty sure we got that right. All right, last slide of the video. All right, in class we're going to work on translating simple problems into equations. So here's the first one. Let's do it together. Half a number plus 5 is 11. Half a number plus 5 is 11. Now the difference between this and translating expressions is now we have to use our ability to recognize the verb to be. In this case the word is. That's my equals sign. Is 11 means equals 11. Ta-da, we got that part. Okay? Half a number plus 5. Plus 5, that's easy, plus 5. Half a number, that's 1/2. And then your variable, I'm going to use n. Now, I know it says right and solve, so let's go ahead and solve it real quick. We'll subtract the 5 from each side, leaving 1/2 n equals 6. And then how are we finishing that off? We're not dividing by a half. Instead, we're multiplying by... That's right, we're multiplying by 2. 2's cancel, n equals 12. Careful, that looks like a subtraction sign, but it's multiplication. I'll make it a big dot. Woo, big dot. All right. Congratulations, folks. That's it for your video. And now I bet you are solving problems like a boss. So I appreciate you watching. Go back and take notes if you didn't already, and I will see you in class.